Good day, viewers. You are welcome back to Alifactic Teaches. Today, we are going to be looking at mathematics, and the topic is a continuation of our trigonometric ratio. Now, we want to look at how to find the angle of a given right-angled triangle. If you can recall, we have dealt with finding the sides of a given right-angled triangle. Question 1. Find the value of the marked angle in the figure below. Given this particular angle, we want to find the value of this angle theta in this place. Before you can do this, you have to label the parts of this triangle. Don't forget that any side facing the given angle is your opposite. So these are our opposites. While the side facing this right angle triangle, this bus 90, the side facing is our hypotenuse, and the remaining side is our adjacent. Now, given our opposites to be equals to 12 centimeter, our hypotenuse to be equals to 15 centimeter, our angle, going back to our SOHCAHTOA, which one contains the opposite and hypotenuse? Yes, that is so. Then we write the formula. Sine theta is equal to opposite over hypotenuse. So sine theta is given as the opposite here is 12 divided by hypotenuse 15. So our sine theta is equal to 0.8. Now, I'm looking for my angle theta. So theta will equals to arc sine. So this is arc sine 0.8. So our theta equals to, how do we find this? We press shift or second function in our calculator, then press sine. It gives us this particular sign, arc sine. Then press 0.8 equals to. So when you do this, it gives us 53.13 degree, which you can approximate to 3 significant figures to be 53.1 degree. That is the value of theta in this triangle. Question 2 reads thus: the perimeter of an isosceles triangle is 23x. If the base is 7x, find the angles of the triangle. From this question, we have perimeter, isosceles. We need to understand the two terms. Perimeter refers to the addition of the sides of a given object, while the isosceles triangle is a triangle that have two sides equal. In this case, two of the angles of the base angle are also equal. Let's have an isosceles triangle this way, in which this side equals to this side. Then, if the two sides are equal, the base angle are also equal to each other. Let's call this theta and theta. Why let's call this one alpha, since both are the same. Let's say A, B, and C. The question says, if the perimeter of an isosceles triangle is 23x, the perimeter, let's say P equals to 23x, perimeter of this triangle is 23x. Since we know that perimeter means the addition of the sides. If this is our capital letter A, the side here will be small a, capital B, small b, capital C, small c. The question goes thus: if the base is 7x, this is the base, this is 7x, then perimeter, as we define, equals to addition of the sides, addition of the sides. So from here, our perimeter is 23x is equals to, the sides here we have A plus B plus C. So 23x is equals to A plus, so our side A here is given as 7x plus B plus c. From here, let us collect like terms. Let this comes here. 23x minus 7x is equal to b plus c. So 23 minus 7x gives 16x. So we have 16x is equal to b plus c. Let the unknown come to the left-hand side. B plus c equals to 16x. Since from this triangle, this sign means they are equal. B equals to c equals to 16x. They are two different sides. That is divided by 2. So we have b equals to c is equals to 2 here, 1, 2 here, 8. That is 8x. So the value of b here is 8x. The value of c here is also what? 8x. So that is the sides. But the question says, find the angles of the triangle. So we move on to find the angles. Don't forget, these base angles are equal. Now, from this triangle, let's try to divide this triangle into 2. When we divide it into 2, then this line has divided this base into 2. So 7x divided by 2. Let's call this place D. So this is 3.5x, 3.5x. So we take one particular side out. Taking one side out, I can take this one. So this is my bus 90, A, D, C. So I have 3.5x here. Don't forget my B here is 8x. Then I want to calculate angle theta, this base angle. From this angle, we have to label, these are our opposites, these are our hypotenuse, and this is my adjacent. Don't forget, any side facing this your given angle is the opposite. Any side facing this bus 90, this side is facing this bus 90 is your hypotenuse. The remaining side is your adjacent. Let us list our parameters. We have adjacent to be equals to 3.5x. Then we have our hypotenuse to be equals to 8x. Now, checking out our SOHCAHTOA. SOHCAHTOA. We have adjacent hypotenuse, that is K. That is cos theta equals to adjacent over hypotenuse. Then cos theta equals to my adjacent is 3.5x divided by hypotenuse 8x. S goes in x. Cos theta equals to, so when you divide 3.5 divided by 8, so we are going to have 0.4375. 0.4375. My theta will equals to arc cos 0.4375. Now, going by our calculator, press shifts or second function, then press cos. It gives us this sign. And press 0.4375. It gives us the values to be equals to 64.05 degree. So this is the value of angle theta. So this base angle here is 64.05. Likewise, this one is 64.05. Now we want to calculate this alpha, this angle alpha. Don't forget that sum of angles in a triangle equals to 180 degree. Now, alpha plus theta is equal to 180 degree. Sum of angles in a triangle. So alpha plus our angle theta is 64.05 degree. The second one, 64.05 degree, is equal to 180 degree. So alpha plus, so when you sum up 64.05 twice, you are going to have 128.1 degree. 128.1 degree is equal to 180 degree. So let's collect like terms. Our alpha equals 180 degree minus 128.1 degree. So the value of our alpha, when you press our calculating machine, we are going to have 51.9 degree. So that is that we are able to find the three angles, alpha, this theta, and this theta. 3 readers. A ladder 72 meters long leans against the wall with its lower end on the ground, 5 meters away from the wall. What angle does the ladder make with the wall? Now, we all know when we talk about a wall always stands vertical. A wall always stands vertical. So when you look at this particular board, drawing a line from this top downward this way is a vertical line, and it is how a wall looks like. When we have a wall, a ladder leans on the wall. The ladder leans on this wall this way. So your ladder will always lean slantly. A ladder 72 meters long. The length of this ladder is 72 meters. Leans against the wall with its lower end. The lower end of this ladder on the ground. The lower end is on the ground. Since it's on the ground, it is now 5 meters away from the wall. This is my wall. This lower end is 5 meters away from that wall. It means from this wall away. So it's now 5 meters. So don't forget, when you have your vertical and horizontal, we have bus 90. Now the question is, what angle does the ladder make with the wall? This is a ladder, this is a wall. So the ladder and the wall has a contact at this point. So the angle here, let's call it angle alpha. So we want to find the angle, this alpha. Now, let us label our right angle triangle. Where this alpha is facing, the side facing is your opposite. Your bus 90, the side is facing is your hypotenuse, while the remaining side is your adjacent. Now, listen our parameters. Opposite is equal to 5 meters. Our hypotenuse is equal to 72 meters. From here, checking your SOHCAHTOA. Which one contains opposite and hypotenuse? Definitely sine. So we write sine theta equals to opposite over hypotenuse. So sine theta equals to my opposite here is 5 meters, 5 over 72. Sine theta equals to, taking our calculating machine to press 5 divided by 72, it gives 0.0694. 0.0694. Here our theta equals to arc sine 0.0694. So our theta equals to arc sine 0.0694. So when you press second function or shift in your calculating machine and press 0.0694, we actually get 3.98 degree. So that is the angle between the wall and the slant ladder. Question 3. The question goes thus: a ladder 72 meters long leans against the wall with its lower end on the ground, 5 meters away from the wall. What angle does the ladder make with the wall? Now, to solve this question, we are given that a ladder 72 meters long, the length of the ladder is 72 meters, leans against the wall. And we all know when we say a wall is always standing vertical. So if I should draw a line from this point down here, that's a vertical line. That is how a wall stands. So let's say we have our wall this way. This is our wall. Then a ladder wants to lean on this wall. This is a ladder leans this way. This ladder is now 72 meters long. Now, this ladder leans against the wall, which is lower end. This is lower end of the ladder. 5 meters away from the wall. So this is our wall. The lower end of the ladder is 5 meters away, meaning from this wall, 5 meters away. So 5 meters to the base of the ladder is 5 meters. Now, when we have a vertical and horizontal, we have a bus 90 there. Then the question is now, what angle does the ladder make with the wall? This is a ladder and the wall. Where the ladder and the wall meets, they meet up here. So we want to know the angle that is here. Let's call it alpha. Now I want to calculate this angle. Now, if this is our angle, the side facing this angle is our opposite. So this is our opposite. If this is my boss 90 degree, the side facing your boss 90 is our hypotenuse. Then the remaining side is our adjacent. So from here, we have that our opposite is given to be equal to 5 meter, and our hypotenuse is equal to 72 meter. So my opposite is 5 meter, hypotenuse is 72 meter. So my formula to use when we look at your SOHCAHTOA, having your opposite and hypotenuse, we have SO. So we have sine, our angle here is alpha, sine alpha equals to opposite over hypotenuse. So let's put our values here. Sine alpha equals to my opposite is 5 divided by hypotenuse is 72. So sine alpha, when we divide 5 over 72, we have 0.0694. Then alpha will now equal to arc sine 0.0694. Don't forget the way we get this arc sine by pressing your second function, your phone, or shift, then press this value. So we have alpha equals to, when we press 0.0694, it gives 3.98 degrees. Don't forget to subscribe to this channel and click the notification bell for my subsequent lessons, and don't always forget to share and like for other learners to also benefit. Thank you very much.